Dear audience, welcome to the NT podcast, Science and Theology. Today we have a special guest, Dr. Robin Collins, a leading expert in philosophy of science and religion. Dr. Collins, welcome.
Well, thank you. Good to be here.
All right, I appreciate your time. I really appreciate your knowledge on this field because we are going to talk about the fine-tuning argument of the universe. Is the precise balance of physical constants just a coincidence, or does it point to a deeper explanation? So, Dr. Collins, I have some objections, but can we start by defining God? What is your definition of God, and what do you mean by that term?
Well, what I mean is I start with the idea that, there has to be there's either three alternatives for what's fundamental to reality. That means what reality that doesn't depend on anything else and everything else depends on it. So it's consciousness is either fundamental or the unconscious is fundamental or some combination of the two. So I start with the idea. It seems plausible to think consciousness is fundamental. And if consciousness is fundamental, then there's nothing external that limits it. So unless there's some internal limitation, you would expect that consciousness to be omniscient and omnipotent and also perfectly free. So you can then think of it's the underlying reality, but underlies everything else is a person who is omniscient, omnipotent, and perfectly free. So as far as you go back, it's personhood. And then that consciousness has knows all possible worlds, which means has representations of all possible realities, and then can, because of omnipotence, omnipotent will, can bring any of those about, give being to any of them. So that's kind of the starting idea of God. So it's not a God out there as much as a God that a consciousness and person, which would be consciousness and will, which go together, that underlies everything else, and then not only has created this world, but sustains it in existence. And then you can get from there, from that, you can get the perfect goodness of God, because if being that is, I use Richard Swinburne's idea that if a being is perfectly free, which doesn't have any internal limitations or external limitations, and recognizes something as good, then they will be motivated to bring it about. Just like if you recognize something as good for you and you have no desires or motivations to push you in the other direction, you would be motivated to bring it about. So God then is perfectly good and has a perfect aesthetic sense, because I think the same thing about beauty is that beauty is intrinsically something intrinsically desirable. So you can think of also goodness as something intrinsically desirable. So that gives God a reason always to bring about the good state of affairs, making God perfectly good. So that's how I think of God, as an unlimited consciousness and will. And because of that unlimited nature is perfectly good. That's good enough for now, because I could say something more about that in response to a particular objection to God, against the existence of God, is the "who designed God" objection. And it's the leading atheist objection to design arguments, which the fine-tuning is one of them. So the idea goes back to David Hume. This objection goes back to David Hume, which says that the order in God's mind would have to be just as coincidental, just as much in need of explanation as the order in the universe. And others have stated that the designer of an artifact must be as complex and therefore in need of explanation as the artifact itself. What they fail to recognize, once you start with this notion of God, the God's mind is ordered, but it's ordered by these possible worlds, these representations. And so those philosophers who hypothesize possible worlds to explain possibility and necessity, and there's a lot of people that are non-theist philosophers. It's to do that, they think all such representations exist. So it's natural to put them in the mind of God, and then there's nothing contingent. It's self-explanatory. Anything that necessarily exists is self-explanatory, just like God would have complete knowledge of mathematical truths, and that knowledge or which would induce some kind of order in God's mind, distinction between different things, would exist of necessity. So 2 + 2 = 4 couldn't be other, and so it's self-explanatory. So I think you got to get the right starting point to answer that objection, so that the God hypothesis completely takes away the coincidence. It doesn't just push it up one level.
Yes, incredible answer. I agree, and good. Yeah, you defined God, but now can you define the term fine-tuning? Because some people argue that the term itself implies a designer who finally adjusts things in the universe, which they see as unfair from the outset. So, can you define what do you mean by fine-tuning?
Well, fine-tuning should be defined independently in this context of belief in a creator. It just means that the universe is structured in such a way that if it were very slightly just um, different, life wouldn't exist. So that's would be the fine-tuning for life. So it has to be very precisely set. It's much like if you had, a radio station that would come in and only at, let's say, 87.111 megahertz. Then the dial would have to be just right for that to come in. Even if you think the dial came about by chance, its setting, it would have to still be just right for that to occur. So that's the idea. Whether or not you think it doesn't, if it's properly, it brings to mind a fine tuner, but you can define it apart from that.
Okay, what are the best examples in the universe or constants or anything else that show this fine-tuning? Can you give some examples of that?
Okay, so first of all, from a modern physics perspective, what's the structure of the universe is given by mathematical laws, rules, like the law of gravity tells you how much masses attract each other according to Newton's law, his formula. F force equals the gravitational constant times one mass times another divided by their distance squared. So the force that the Earth exerts on you is given by this number g times your mass times the Earth's mass divided by the distance between you and the center of gravity squared. That would be an example of a mathematical rule. Now, you have to have so there's first the fine-tuning of the mathematical rules. There has to be the right mathematical rules. So if there wasn't any gravity, there wouldn't be any stars or planets, no place for life to evolve. Okay. And you have other mathematical rules like um, electrons and protons attract each other, or you have rules that govern nuclear fusion. So that's the laws of nature. And you have to first, so there's a sort of fine tuning that's often neglected of just having the right sort of rules. But then in each of those rules, there's a specific constant that specifies that's a number, like the constant I mentioned, that gravitational constant in G. So the force is proportional to that constant in G. So if you were double G, you would weigh twice as much. And the force on you would be twice as much. If it was 1/2, your weight would be 1/2 as much. And so that's critical because within those rules, there's something has to determine the exact amount, for example, of gravity. Or if you look at the electromagnetic force, like electric force, something has to determine the amount of force between, let's say, a proton and an electron. And likewise for all the laws of nature, there's these fundamental numbers. So there's the laws of nature, then there's the fundamental numbers. And I'll talk about a couple of other examples of those that need fine tuning. And then there's a third thing, which is the initial distribution of mass energy in the universe. So it's like three different things have to go in to having the universe with some any kind of universe, physical universe. There's three components to it. Now, the most of the focus has been on the fundamental constants. They're really, I call them, they're better named fundamental parameters because we don't know for sure. There might be slight deviations of them in different parts of the universe, and we don't know that for sure. So these fundamental parameters are like the number G. They're also various masses, like the mass of the proton or mass of the neutron. They're near fundamental. They're actually a result of their constituents, quarks, and the strong nuclear force. So there's those things that go in. Now, all those have to be precisely adjusted for life to occur. One of the most discussed in the cosmological literature is what is called the cosmological constant, and it's usually thought of as equivalent to the dark energy density. So space is filled with energy called dark energy. And that can be over a huge range of values that dark energy could have been theoretically possible within our models. And that has to be fine-tuned to one part in like 10 to the 120th power. That's 1 followed by 120 zeros. And why is that? Well, the dark energy acts as a repulsive force. So the universe expands from the Big Bang, and the dark energy causes it to expand faster than it would. And at some point, the repulsive force of dark energy remains constant because of the nature of the dark energy. Whereas gravity, because mass is spreading out from the Big Bang, the force of gravity weakens, and eventually the dark energy becomes the stronger force. That happened about 5 billion years ago. And since then, we've been undergoing accelerated expansion. So if that's too large, the universe would have early on, before 9 billion years ago, expanded too rapidly for galaxies to form. And if galaxies couldn't form, then there couldn't be stars and life. And there needs to be stars like supernova for the elements. So that's one example. Another example is nuclear fusion depends on, that we have in the sun, depends on the neutron being heavier than the proton, but it can't be too much heavier. So it has to be within a fairly small range of being heavier for nuclear fusion to occur. And for example, if it wasn't heavier, then all the protons would have go to lesser energy state, would have become neutrons, and there wouldn't be the kind of nuclear fusion you have. If it was too heavy, then the nuclear fusion couldn't occur because the two protons combine together, and then as they fuse, one of them changes to a neutron. And if it's too heavy, there's not enough energy released in the fusion process for that to occur. So that's another example. Gravity has to be, if the force of gravity were too large, you couldn't have stars that lasted very long, not enough time for evolution to occur. Similarly, worst problem is that as you increase gravity to keep a planet with an oxygen atmosphere, which you really need for higher level organisms like us, or an atmosphere at all, actually, other than just hydrogen. If you start increasing G, then you would also, to retain that atmosphere, you have to have, you'd have to increase the mass of the planet, which would result in actually have to decrease the radius, and that would result in the surface force becoming larger and larger to such a point beings like us can no longer really inhabit the surface. So there's a lot of different effects you could talk about. So those are some examples, but easier examples to grasp actually are the laws of nature, the fundamental principles. Like if there weren't, uh, like I said, the gravitational attraction, then there wouldn't be any life. If there wasn't a force of attraction and repulsion of electric force, there wouldn't be any life because you couldn't even get the building blocks of atoms. And then along with that, there has to go magnetic force. So it has to be a principle where the electrons move, give rise to a magnetic force to get light rays, which allow the transmission of energy from a star to a planet. If there wasn't that transmission of energy, life could only, the only possibility is to exist to get energy is on the surface of a star, but you'd completely disintegrate there. So, and then there's other ones like the Pauli exclusion principle that keeps matter solid and from all collapsing in on itself. So there's a whole bunch of these kinds of things. It's probably about 12 to 14. If you took one of them away, you wouldn't have life. And then finally, there is the most impressive of them all is the initial arrangement of mass energy. We all know about, most of us have learned a little bit about how entropy increases. Things go from order to disorder. And that's the process that allows for like us to drive a car. It's really driving the car a lower entropy state of the matter, more organized state in gasoline is changed to a higher entropy state. The energy, because energy is conserved, remains the same. So really we're using up low entropy when we drive a car, not energy in the absolute sense. We're using up low entropy energy. And so that means that the universe, in order to have stars and galaxies and life to develop, would have to have extremely low entropy start off with. And then the entropy gets higher and higher. And if you calculate, and then that organization, physicists have a way of measuring the kind of possible states that matter could be in, possible arrangements. They call it phase space. It's like two coins have a phase space of either being heads, tails, tails, heads, 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 or tails, tails. Would be four possibilities. Well, there's an enormous number of possibilities for the initial distribution. And in order for life to occur, it has to be, of those possibilities, a staggering 1 part in 10 to the 10 to the 123rd power. That's 10 raised to 10 to the 123rd power, just to get an idea of how big that number is. If you had a printer and it was God's printer and could just print huge numbers of paper at once, trillions of sheets, and you had all the sheets filled with zeros, and you just printed it and you filled the whole universe, which is huge in size. And you put a 1 in front of all of them, that number would be smaller than the number I'm talking about. So the precision is just absolutely enormous that you need to have life. Now, there's a further story on all that, and that's what I've been working on for the last 10 years, is it's also very fine-tuned for scientific discovery so that we don't just have life, but it's a further deep fine-tuning of the universe for scientific discovery. And I could talk more about that. That's my actually current research, which I'm finishing up on.
Amazing. Thank you. Can you please continue? Because that's my really question. Is fine-tuning argument only restricted to life permitting universe, or it is applied on something else?
Well, it's applied, so it's really observer permitting, observers like us, but then it also is fine-tuned so we can discover the universe. So one of these cases that's sort of already in the literature that people didn't notice was the that low entropy I talked about. It's often been pointed out that, I mean, like by Sean Carroll, who's an atheist cosmologist, pointed out that you could have got life if just a local region of order, let's say our solar system or our galaxy. We don't, it's much, you have to have much more order to get the entire universe ordered. So it's like a Scrabble, or it's like you could think of a Scrabble board. If you shake a Scrabble board, occasionally you might get the Scrabble would be in line to spell a word. But it'd be vastly more improbable for the whole board to be ordered, into words. Or if we had like um, coins lined up 1,000 in a row. Well, occasionally you'd get five and order five or even maybe 10 coins that are all heads. And that'd be vastly more probable than getting all of them heads in a row. Because the larger the region of order, the probability of that happening goes way down. So then we would have expected ourselves the entropy just to be low enough to for and just the life permitting constraints. It's far more probable if that's all you're trying to do is get life permitting just to make a small region that's life permitting, or if it happened by chance, if the universe, this was just a chance arrangement, far more probable for a local region. In fact, it's far more probable for it just to be a region of a brain, which then leads to everything else being chaos, which is called Boltzmann brains. Being a Boltzmann brain is far more probable. But even if you wanted to have like an Earth-like planet, it's far more probable for it to be isolated, the solar system to be organized and the rest to be disordered, and then, or just have a galaxy and that's it. But as we have it, it's all ordered. And that all ordering is actually needed for scientific discovery. If we didn't have that, we wouldn't have discovered the Big Bang Theory. We wouldn't have been able to know about how stars work. All that sort of thing requires a much larger order. So you could see in that way, it's the best it could be for scientific discovery. So that's one example of that. Now, there were some early examples. We want me to go into this more. So I started noticing that the universe seemed to be arranged for scientific discovery. Now, has been noticed before, but on a different level. So Albert Einstein said the most miraculous thing about the universe is that it's intelligible at all. And for those who don't know, Albert Einstein was the greatest physicist of the 20th century, and many think the greatest physicist since the time of Newton. And then Eugene Wigner, another prominent physicist during the 20th century, wrote a famous article called The Unreasonable Effectiveness of Mathematics. And he said that it's miraculous how effective our mathematics we come up with is. And even Steven Weinberg, an atheist, says sometimes it seems really uncanny that our mathematics work so well. So those are all examples. And then somebody wrote a book, a philosopher wrote a book about that. Examples at the level just of the mathematical equations that the universe is highly ordered, so that we can discover it. What I did starting in 2010, the idea came to me. I wrote a little bit about that before, but then the idea came to me, well, if you had a providential explanation for this, then you would think this fine-tuning for scientific discovery would go even deeper to the constants, right? Why wouldn't you adjust the parameters so they're optimal for scientific discovery? So that's what I started looking into. And the first case I ran across was, it's not in the end the best case to make my case, the most powerful case I can for fine tuning, but it's very good for illustration. And that is the fine structure constant. That's a parameter that controls the strength of the electromagnetic force. So, and it determines, so remember there's G, the gravitational constant controls the force of gravity. the fine structure constant controls the electromagnetic force. And remember, there's the electric force, magnetic force. They're combined together by James Clerk Maxwell in the 1800s to give rise to the electromagnetic force. And that's and when he gave the equations for that, he predicted radio waves. So, and that was, I think, one of the biggest discoveries in all of human history because it gave rise to all of our technology, a huge amount of our technology we have today, motors, all that kind of thing. So those two are combined. Their strength is governed by this fine structure constant. So you can show quite easily, actually, and other physicists have checked over my work on this, is that if you the fine structure constant, one thing it determines is the amount of radiation that a fire emits. When you stand around a campfire or feel around a candle, you'll feel the heat energy coming from it. So if you double the fine structure constant, what that would do is you'd feel twice as much energy coming away. And to show this, you use special units called atomic units, which everything else remains the same in those units when you change this fine structure constant. The world looks the same, except for how much radiation is produced by fire or things that are hot. And so the end result is it's proportional to the square of that fine structure constant. If you increase it very much at all, compared to its possible range of values, so much radiation is emitted that a fire will go out. So what's the significance of that? Well, if fires would just go out, we couldn't have campfires. We would have never found out about how to smelt metal. There wouldn't have been ever Bronze Age. There wouldn't have been an Iron Age. There wouldn't have been any kind of modern technology. And then there's effects that you go the other way. The efficiency of electric transformers rapidly decreases, and they're all used in our electronics. Like we plug our laptops in, phones in, all through transformers. Motors would have rapidly got less efficient, and also the light microscope its maximum resolving power is proportional to the fine structure constant. In other words, it depends how you define maximum resolving power. Let's put it this way. Right now, you can see 0.2 microns, millionths of a meter. And that's actually the smallest living cell. You need light microscopes to see smallest living cells. And a living cell, you can't see it without that. So it's just strong enough to do that. If you started decreasing the fine structure constant, you would get, you couldn't see the smallest living cell anymore. And progressively, light microscopes could get worse and worse. And you can't see living cells with electron microscopes. So it's just in the small region that allows for fire, and so allows for the technological civilization, but it also is good on these other ways. If you start moving it, decreasing it, yeah, fire would be better. You'd be able to more easily keep a fire going, but you'd be a lot less good for these other things. In fact, it would be too easy to keep a fire going, which would be more forest fires and things like that if you decreased it from where it is. So we're in a very small region that's very good for scientific discovery in an overall sense. And that was one of the first cases I ran across. There's a whole bunch of other impressive cases. I now have a whole bunch of these that are very precise. And so I think there's just an overwhelming case for it. But I could go into more of that.
Unbelievable. Thank you so much. And now, how can you go from fine tuning to God? The definition you provided at the beginning, because yeah, what is your argument? What is your best version of fine tuning argument? Can you say premises and conclusion that go to that definition of God that you said?
There's a couple ways of doing it. One, if I went back to my coincidence, God takes away the coincidence. So usually huge coincidences, we require some kind of explanation, but we want the explanation not to be just as coincidental as the coincidence itself. So if I toss a, two-sided coin 100 times, 1,000 times in a row, and it always comes up heads, you wouldn't accept that as just by chance. You would be looking for a coincidence. Maybe it was, heavily weighted on heads, or maybe I had some device that always flipped it to heads, but you wouldn't accept it happened by chance. So that's just the simplest way of thinking about it. So if you think about it that way, it's so outrageous to think that all this fine tuning came by chance, not outrageous under the God hypothesis. Therefore, the God hypothesis makes much more sense. Another way you can do it is, which I had preferred, is the Bayesian way, which is that if one data makes more sense on one hypothesis, or is more likely on one hypothesis than another, then it strongly confirms the hypothesis is more likely on. So, in a courtroom, if we have DNA evidence and fingerprint evidence that the defendant is guilty, why do we think that points to the defendant being guilty? Is because the defendant is innocent. It's very unlikely that the DNA would match the defendant's DNA. And I mean, they don't check all the DNA, they just check some strands. Or always could be somebody else whose DNA matched, and likewise for fingerprints. But it's just very unlikely under the innocence hypothesis, not under the guilt hypothesis. So strongly confirms the one over the other. And that's just part of standard Bayesian confirmation theory, what it's called. So here the idea is it's just extremely unlikely, in a sense of what they call epistemic probability, is that it's hugely surprising, would be unexpected, and under God, but not under God. That's another way you could go with it. So um, I just give two different ways of going with it that you could get the support for God. Now, critical in each way actually is that the God hypothesis is not as much in need of explanation or as coincidental as the thing being explained. Because if it is, then you don't, you just back to the, didn't back like the coincidence, and you're just back to the huge coincidence that God exists, and you're no better off. And that can also
Right,
be
but
worked out in probability theory. So it's very
yeah,
good you
but
asked me that question at the beginning. So then there's another piece to fill in that argument. Why does God hypothesis explain this? You can see this in the Bayesian formulations. You want it to be not improbable that God would create a world that's fine-tuned. So that goes with the idea of God being perfectly good, which you got out of that initial consciousness being fundamental. So God being perfectly good means that the reason why God would do anything, the ultimate reason, is because of its goodness. So God creates good state of affairs. So then since you can glimpse or at least perceive it's plausible to think that embodied conscious beings like us it's good for beings like us to exist. Then we have a reason why God would create such a world, and it takes away its enormous improbability. So actually, you can go further there and combine this with the problem of evil. And the way to do that, so then you don't have problem of evil over against the fine tuning. You have the evidence of fine tuning plus the evil in the world supporting God. And the way to do that is we are not just embodied moral agents or embodied conscious beings. We're highly vulnerable embodied conscious beings, meaning we're vulnerable to environment that comes with the embodiment, and vulnerable to doing moral evil. So once you have such beings like that, and they're highly vulnerable, means also God wouldn't just be intervening all the time to stop it. Otherwise, we wouldn't be vulnerable. And you say, well, highly vulnerable beings, there's a good you can perceive that they realize. And that is such things as self-sacrificial love. If you're not vulnerable, you're not vulnerable to suffering, and you can't give self-sacrificial love to another. Courage, all those sorts of things come out of the vulnerability, but so does the evil. So then you would actually expect um, the explanation for the evil in the world is our vulnerability to evil and vulnerability to our environment, and the fact that God doesn't intervene, all that have to be there for us to be highly vulnerable, embodied conscious beings, and for that good to be realized. So then you have a fine-tuning plus existence of evil argument. And then since it's you can perceive a reason for God doing it, it's not highly improbable for this kind of world to exist. But because this kind of world requires such enormous fine-tuning, it's enormously improbable under atheism. Or at least what I call naturalistic single universe hypothesis. We have to get into that. That's another one of the major atheist objections to fine-tuning. So it's enormously improbable under that, or enormously coincidental. Therefore, you have this really strong argument for God. So that's how I go.
Yes, thank you. And why it cannot be God with limited power or demiurge or something in pantheistic framework or anything else, deism. So why it must be perfect being responsible for fine tuning?
Well, that goes back to the coincidence issue. If you had like a God who wasn't omnipotent, let's say, and there was pre-existing, let's suppose you had pre-existing matter, and this fundamental, two things were fundamental, this consciousness and pre-existing matter, and um, that God was limited by the pre-existing matter in some way. So you imagine several scenarios, limited God, that's kind of limited by material conditions. Then there'd have to be complex laws governing that limitation, like complex laws between governing God's mental states and what happens, what this mental state can bring about that in the world. So it looks like that would need a lot of fine tuning. So you'd be back to a fine tuning problem and you wouldn't take away the coincidence. So at least the all powerful God, first of all, you need to all extremely powerful, as otherwise it couldn't create a universe like this. But then the creation, if to get away from those like what they call psychophysical laws linking one's psychology with other things, to get away from a fine tuning there, you can't have a God who's like a demiurge. The demiurge is restricted by matter, and Plato's can only do certain things, can only put matter together imperfectly. Or you can't have a committee of gods, because if you have a committee, then there's a whole bunch of laws have to determine who can do what, right? When two wills come into conflict under the committee, then what determines which will wins? And so we know what determines how our wills interact as a whole physical world, and the laws linking our mental states with the physical world. So it looks like you're back to a kind of fine tuning. Because I think that the one at least you can plausibly eliminate the fine tuning. You don't have with the consciousness being fundamental. And so consciousness and other things are limitations. Then you have to have some kind of coincidence or explanation of why there are those limitations, which you don't under consciousness being fundamental.
Okay, thank you. And
So maybe
now,
I wanted to say one other thing about this is, this is the problem with an alien in a universe, we're a bubble universe within a larger universe. And the alien, if for fun, created this universe. Well, then you've run into the same problem with the alien's universe. It would need some sort of fine tuning, right, for the alien to function. So anyhow, you can kind of see it in that case.
yeah, awesome, thank you. And now, some people argue that the universe isn't fine-tuned at all, but this is a little silly after all that you said before. But They say the very fact that I can get out of bed and trip shows me that it's not fine-tuned, simply because death exists at all. It is not fine-tuned. For example, Neil deGrasse Tyson says that we barely survive, that the universe is extremely hostile and deadly. When he observes supernova and various phenomena in the cosmos, he doesn't see God anywhere. How is that fine-tuning?
Well, it's all that shows is it's not fine-tuned for life to be everywhere in the universe, but it still needs to be fine-tuned for life to be anywhere and beings of our level of intelligence. So I don't see why he's assuming that if God's going to fine-tune it, God would fine-tune it to be chock full of life. But why assume that? You would assume that maybe if God was like a engineer that was limited in resources, then you'd want to get as big as bang as possible. But why assume that's going to be life everywhere? There's not going to be a lot of dead stuff. So I just don't see the problem there. It's still fine-tuned for life to exist somewhere.
Yeah,
And
but we can die somewhere. We can jump from floor and be killed. It's not fine-tuned in
it's
Earth.
not fine-tuned so that we live forever. That's part of the design plan. And there's problems with living forever in our kind of world. If we are highly vulnerable embodied conscious agents and we can, through our free choice, can affect each other. If we could live forever, then somebody could become a dictator and remain a dictator. At least like Stalin, death ended his dictatorship, right? You can't, because we're finite beings. So, and faith, if you believe there's an afterlife and things like that, facing death is a very valuable thing to recognize our own immortality. I don't see any reason why God would have created so we can live forever. I think it'd actually be something, if we invented a means for us living forever, I think that would be a bad thing, actually. I don't want to, in this form of life, continue existing forever. You get very bored. So I think the fact that our material life on this world is finite is not a bad thing. So it's fine-tuned that we have intelligent, highly vulnerable embodied conscious agents. That vulnerability includes vulnerability to death.
All right, I agree. Thank you so much. And this is one longer and very popular in these days because Alex O'Connor said this objection, and that's like main one. So, on theistic view, God as a perfect being is not bound by the physical constraints of our universe. He could have created a completely different set of physical laws. Even a periodic table where water is, for example, just H, not H, 2H and O. So why then should the parameters of physics be relevant to arguments for fine-tuning? If God intended to create a life-permitting universe, he could have chosen any set of parameters to achieve that goal. Comparing the probability distribution of physical constants under theism versus naturalism seems meaningless because in theism, no matter what values are chosen, a life-permitting universe could always be created. Couldn't there be a universe with no Earth, no planets, just a vacuum with life existing in it?
Okay, so couple of responses. First, we don't know that. And it certainly, so he's imagining different law structures, right? So there's still a fine tuning in the sense that given our law structures, the constants have to be just right for the parameters have to be just right for the existence of life. So it is a little bit like, and all we can really see is our own law structure. So it's like if you had a dartboard, let's say a huge dartboard that just extended for miles and miles, or kilometers and kilometers, and it was all dark. And there was just this beam, flashlight hitting this point right here that you could see. And within that little illuminated region, there was a very, very, very small bullseye, and you saw a dart coming and it hit that bullseye, you would still say that has to have been aimed. And even if somebody said, well, maybe there's lots and lots of other maybe there's lots and lots of other bullseyes. The other parts of the dartboard are chocked with bullseye. That's a speculative hypothesis. Well, then you could ask, well, first, you don't know that. But if they were, as you hypothesize, then what you would expect, you'd expect the dart to have hit one of those other ones instead of this one. Why did it hit the one that you illuminated? And then that really small region, you'd still conclude it must have been aimed, because if it wasn't, then why would it have hit there? So that's one answer. Another answer is that there's a good reason, there's a further reason, even if that were the case, there's a reason why God would have created a universe like ours. And that really links up the fine-tuning for scientific discovery. Part of what, and my deeper hypothesis in the fine-tuning for scientific discovery, is God wanted to let us know that actually the universe was created at a deep level. And so if God wanted to let us know that, then God would have created a set of laws that is very fine-tuned, if that was part of the purpose of letting us know through the physical world. So that's also assuming that fine-tuning doesn't serve any other purpose. But us knowing it's fine-tuned gives us good reason to believe it in God. But it's a kind of reason that's apart from God just directly telling us. Maybe God wants us to find out ourselves through doing our science. So that's a couple answer. The first answer, I think, is good enough, because if they were right, and if there was all these other law structures that allowed for life, one thing you could also say is then we would have expected to find ourselves there, not one that requires, under atheism, we would have. So they're going to run it. That hypothesis runs into a problem for them.
Amazing answer. Thank you. And how you address those famous answers for explanation of fine tuning, for example, multiverse hypothesis, or yeah.
Okay, the multiverse hypothesis, there are several ways of addressing that. First, as I initially, when I wrote on this, if you can either do two kinds of multiverse. One kind of multiverse is that's generated by a physical process. That's the most popular kind that's usually put out. But then to generate you'd have to have a physical process that generates universes. So an analogy I give is that when I say that physical process itself would have to be extremely fine-tuned to generate even one life-permitting universe, let alone a huge bunch of universes. So why is that? Well, think of, like, I used to have a bread machine no longer working. It has to have the right program, has to have the right ingredients, yeast, flour, gluten, all the stuff I had to put into it, to even create one good loaf of bread. And it's only creating loaves of bread. If it was trying to create universes, it would have to be extremely fine-tuned. You'd have to have all the right laws. You don't just get universes for free. So you'd have to have all the right laws. And in fact, studies of this show that you'd still have to have extreme fine-tuning of the initial conditions. So under the kind of popular, inflationary superstring scenarios. So that's one answer. But it also does, if there's this fine-tune, there's also a Boltzmann brain answer that, remember, I talked about in the low entropy case. All you needed for life is this small region of order. So if that answer were right and the low entropy was just a result of this random fluctuation, it's far more likely we'd find ourselves in a small random fluctuation, one that extends throughout the universe. And so in overwhelming probability, we would expect ourselves to be in either this small region of order or just a brain with chaos all around us. And those are called Boltzmann brain. That's the Boltzmann brain objection. And the final one is simply the whole project of discoverability. It can't explain why the universe is fine-tuned for scientific discovery. If the parameters are set so that we can optimally discover them, so it's not just that we can discover them, but we can optimally discover the universe, or set so we can like do science in the case of fire. And there's a bunch of other examples I could give. Um, some way even much more precise than that, like, you know, one part, some parameters, 1 part in a million for optimality in certain areas. So if that's right, if there's this extreme fine tuning for scientific discovery, that can't be explained by a multiverse hypothesis, because the multiverse hypothesis relies on the observer selection effect. And let me explain how this works. So here's how the multiverse hypothesis goes. It says, first of all, if there's enough universes that are have different values of the fundamental parameters and maybe different laws, eventually one of them will turn out, and there's variation among them, to be life permitting. Just like if you produce it, I don't know if you have lotteries in Serbia or other areas, but we have them over here. In the US, states have lotteries, and then they sell tickets and lots of tickets. And then if you get the winning number, then you might get like $1 million. Okay. And the probability is always less than 1 million you're going to get the winning number. But you produce enough tickets, somebody gets the winning number. So produce enough universes, somebody gets the win. Some universe is going to be set just right for life. That's part one. So it explains why there's a universe that's set just right for life. Multiverse is how it's supposed to work. But then you might ask, well, why do we observe ourselves in such a universe? And they would say, because you couldn't have observed yourself anywhere else. That's the observer selection effect. Any observer is going to have to observe themselves in a universe that's fine-tuned for life, because otherwise they wouldn't have existed. Okay, that's the observer selection effect. Now, let's look at fine-tuning for scientific discovery. If it's really fine-tuned for scientific discovery, that means there's a fine-tuning over and above this fine-tuning for life. So most universes that allow for life like us aren't very good for discovery. So now the huge coincidence is, and you can't explain this by a multiverse, you have the multiverse. The coincidence is, why do we find ourselves in a universe that's so good for scientific discovery? And it can't explain that. So it basically, for that fine-tuning, the multiverse is dead on arrival. It can't do it, because there's no observer selection effect. Observers could exist in universes not very good for scientific discovery.
Nice. Thank you, Dr. Collins. And what do you say about that objection about brute facts? It's simply fine-tuned, no need for explanation. How you address that argument?
Well, one is the Bayesian way, is that if you think that it's very improbable, and probability can, one way of getting that improbability is there's many other alternatives. Like, it's kind of a principle of indifference you can use. It's why if I rolled a perfectly symmetrical 20-sided die and it came up 1, you would calculate, or 2, let's say, you calculate the probability of that happening is 1 in 20, because there's 20 sides, and it's perfectly symmetrical. Coming up 2 is 1 out of 20. It's just like if you roll 6, if you roll double sixes, there's 36 possibilities you can get, like 5 and a 6, or 1 and a 1. You think it's 1 out of 36. So you're applying the principle of indifference there. Even if you had never seen a die before, that perfect symmetry, if you've never rolled them before, you would say that. So there's all these other possibilities for the values of the constants. And using that kind of idea of probability, you can see why it's very improbable. And it's called the classical conception of probability. But it's not under theism, so it strongly supports theism. So it could be a brute fact. It's just vastly unlikely it is. Now, some very vastly unlikely things do happen. So the requirement is you have a hypothesis that takes away that likelihood. So for example, in the case of the coins, if I tossed a coin 1,000 times, some sequence would come up. Whatever sequence came up would be enormously improbable, that particular sequence. And yet we wouldn't conclude that, there was some explanation other than chance for it, because we can't think of any explanation that takes away that improbability, right? So we can't think of, a weighting explanation that was weighted in some way, or even that somebody did it, because why would they do that sequence versus a lot of others? So the other requirement then is you have to have it has to not only be improbable in the sense there's many, many, many other alternatives that look equally good, but there has to be a hypothesis that takes away that improbability. And that's where you get with theism, it gives God as a reason to create such a universe like ours, so it takes away the improbability so the conditions are met. Another example is like you win the lottery, and let's say it's the world lottery of 5 billion people, right? You win it. So that could be just considered a brute chance fact. But now we find out that your brother is the lottery commissioner, right? And he's kind of known to be corrupt. Now, wouldn't you be really suspicious that your brother rigged it in your favor? Because you'd say, well, it's really improbable that you would have won if on chance, but not improbable, not near as improbable if your brother rigged it. So now, because there's a hypothesis that's we judge not super improbable, because we know your brother is a lottery commissioner, it's not super improbable that he might rig it, then that hypothesis reduces the coincidence a lot, is one way you can think about it. It's not near as improbable under that hypothesis. Therefore, it gives us good reason to believe that hypothesis. So that's what's going on here. It's just a matter of kind of using confirmation theory. If we allowed that to be said, we could then our science would completely be eliminated, because most scientific inference is based on this is a coincidence if it happened on its own, but not a coincidence if this hypothesis is true. Like the confirming piece of evidence that Africa and South America were together, recognized way back in 1915 or around that time, is that the animal and plant life about several million years ago is about the same on both of those continents. But then as time goes on, they begin to diverge. So if they were together, you would explain it wouldn't be improbable that they would have the same, and if they drifted apart, this continental drift theory. And so we think that's strong evidence because the one theory can explain it, where the other theory, they were just always apart, can't explain that because it'd be very improbable. And we wouldn't just call it a brute fact. Oh, it just happened to be that way. We wouldn't say that because we have a hypothesis that takes away that improbability. So likewise with theism.
Okay, but what if a universe would automatically create always in the same configuration all those constants and like some physical necessity? Every time when a universe creates itself, it is set by those constants.
Okay, well, so I'm a continental drift skeptic, and I say just of necessity, things were arranged at the beginning just right so that the evolution of Africa and South America would be identical about 3 million years ago and then diverge. And that happened of necessity. I could do that with anything. And if you allow that in, you're not going to be able to make any scientific inferences at all. So the coin comes up 1,000 times on heads. Oh, by necessity, there's a super determinism that of necessity, all the matter configuration had to be just what it is, and everything had to unfold just as it is to make that happen. And you would first undermine all kinds of inferences. So we normally assume that's false. And then a more foundational reason why that doesn't work is we think it's extremely improbable that the necessities would be arranged that way instead of some other. So we now have the coincidence, and the coincidence is partly an epistemic term, is that there's one alternative that occurred, and we have no reason to think any of the other alternatives um, that is better than any of the other alternatives. And that's the same thing going on here. Would have no reason, like if you were an unembodied being who didn't know about our universe, you would have no reason to think that values of the concept would happen of necessity versus all the other possibilities. So that objection is not going to work for those two reasons. For both, it would undermine all inference. Somebody could always do that, and then that would not only undermine all inference, but there's foundational reasons just by the nature of coincidence to reject that.
Yeah, that's a reasonable answer. But what if the universe has been trying to come into existence repeatedly over a long or even infinite period in the past, eventually reaching this stage where life could emerge? Wouldn't that drastically increase the chances that a finely tuned universe would eventually form?
Yeah, so that's like Lee-Smolin hypothesis. He does that via black holes. It would increase the chance if the constants and parameters and the laws kept getting adjusted every, time it came into existence. So it's a variation of the multiverse hypothesis. Instead of them all existing in some sense simultaneously, they just exist in order, in one after the other. So the same arguments that offered against the multiverse hypothesis work against that one. The Boltzmann brain, that whole process would have to be well designed to do that, to vary the parameters for one universe to give rise to another, or however you're thinking about this. The Boltzmann brain problem, and then the discoverability problem. So you're just back to a variation of the multiverse hypothesis.
Yeah, I agree. Okay. And this is a quote of Sean Carroll. You mentioned him before. So, how you comment this? He said, "Theism, I would argue, is not a serious cosmological model. That's because cosmology is a mature subject. We care about more things than just creating the universe. We care about specific details. At the cosmology conferences, we are discussing these questions that you see before you." So he introduced some tough questions in physics, and he says, "I'm not going to list all of them, but a real cosmological model wants to predict what is the amount of density perturbation in the universe, and so forth. Theism does not even try to do this because ultimately theism is not well defined."
Well, I agree is that it's not a scientific model. I have no problem with that. It's a metaphysical model. It's a metaphysical hypothesis about the ultimate structure of reality. It's on the line of, there's a wide number of people, theists and atheists alike, believe in Platonism as a theory of mathematics because mathematical truths seem to be independent of us. Whether we existed or not, it would still be the case within the prime numbers, in the number system, there wouldn't be any largest prime number. So it seems these mathematical truths are independent of any human being. They don't exist in the material world. So Platonists hold they have a timeless reality. And often theists put that in the mind of God. Well, that doesn't make any predictions. It's a account of why there is those truths. Just like Sean Carroll's view of all there is matter doesn't make any predictions, but he thinks that's the best account, everything considered, of the nature of the world. So his view that there's nothing outside the material world is no more scientific. So they're metaphysical views. And so we shouldn't expect metaphysical views to be scientific. Now, actually, as a matter of fact, if you think of fine-tuning for scientific discovery, that was predictive. But now that's not just bare theism, that's theism plus God wanted us to optimize the world for discovery. So if you add some additional, they call auxiliary hypotheses to theism, that it can be predictive. So that's not even quite true. And most hypotheses, almost all hypotheses, have to make any predictions at all, you have to add auxiliary hypotheses to them, which means additional hypotheses. So, like to explain the orbit of Uranus, would seem to differ from that of Newton's prediction. They hypothesized Neptune, that the next planet out, and it was predicted if you had a powerful enough telescope, you would observe it. So that was their prediction, and it happened to turn out to be true. But that prediction relied on the auxiliary hypothesis that there was no intervening matter that would block your ability to see Neptune. So you really don't, let's suppose you have COVID. So prediction of your COVID hypothesis, you go in for your test strip, it would be positive if you have COVID. But that relies on an auxiliary hypothesis that the COVID's test strip is working right, is not expired, for instance, and that it's not giving you false negative, for instance. So those are examples of auxiliary hypotheses. So all hypotheses, all scientific ones, rely on auxiliary hypotheses. So if you do the right auxiliary hypothesis in the case of theism, you can get predictions. So it's actually not true, but even if it were true, it wouldn't affect, because theism is not a scientific hypothesis, I don't think.
Yeah, that's reasonable. And why most of your colleagues are atheists? I see some paper, it says that 72.8 philosophers don't believe in God, only 14.7 are theists, and others is 12.6. So why do you think that most philosophers don't believe in God in spite of this argument?
Well, I mean, one thing I'd have to look at that survey myself, but there is kind of reason. I think one of the big things for philosophers is that see the design God objection, that God would need to be three things. God would need to be just as well designed as the universe, and I think that objection is faulty. So I think that objection is faulty. And often it's, how a lot of people were raised atheist or grew up that way, especially a lot of intellectuals, so they don't even seriously consider the existence of God. And part of it is intellectuals, that's a more popular people, the more common person has faith, and they see a lot of goofy stuff in religion, which I see a lot of, and so they're just turned off. A lot of, I mean, I'll just speak for the United States here. I see, they're turned off of the moral stances of a lot of religious people, etc. So they don't really, religion then gets associated with young earth creationism, anti-gay, all this stuff for them. And hey, I go to religion, take it seriously. I've been listening to a lot of the atheists recently, Sam Harris, for instance, and the objection always goes back to the biblical God. So they associate the God with a particular religion and a particular view of the Bible, but to kind of popular religion. So that turns them off. And I think in certain legitimately in certain ways, it turns them off. So they don't take the view seriously. Those who do look into it often do convert. Now, I go by saying this of Quentin Smith. This was around 2000. He wrote this article. He started getting this journal. He helped start this journal, Philo, which was like the leading atheist journal. And he wrote one of the first articles for that. And he said, as it is now, if you got, it was a call to atheists to get their act together, because he said if you theist and atheist room, the theists would probably win on the argument side of things. And so we need to get our act together. Theists are beginning to take over in the philosophy of religion area. So I think that's another explanation. And I know among scientists, this is also the case, that a couple more explanations, because this happens also among the elite scientists, particularly. One thing, Francis Collins, he was director of the National Institute of Health under the Obama administration in the United States. He became a theist and a Christian. And he said, while working in biochemistry and biology, he didn't even seriously consider a lot of these questions. And then somebody challenged him or something about reading C.S. Lewis on the moral argument, why there's morality at all. And when he started thinking about the questions, he actually converted. So another thing is they don't often think about the questions. They're not in the area of philosophy, religion. And often, and this goes, I want to also address this for like scientists, because I talked to John Polkinghorne about this, why are the more imminent you get in the sciences, like in the less religious you're likely to be. Well, he said science takes up all your time. To get to that point, you have to devote 100% of your time to science. And to have a sense of, usually it's not just arguments that convert people. It's also, there's a sense of transcendent spiritual reality. And they need to take time in nature or do things that would cultivate that, and often they don't do that because they're all taken up, so they don't sense anything more than this world. And I know how that works because when I've been in physics, especially before I took quantum mechanics seriously, everything just looked like it was my model of the world is fundamental particles. People in biology, they think everything is biochemistry. You see everything through your own discipline. So if you're in a discipline, you're going to see it's all just the way your discipline sees it. So that's a more general, it's not just among philosophers, a more general explanation. Is I don't think often they've seriously considered it. And some just might be resistant to the idea of God, but I think a lot more of it is, like Thomas Nagel says, he's kind of leading philosopher of mind at NYU in his book on reason. He has a short book on reason. He's a leading philosopher. And he says he didn't want there to be a God. That's the main reason. He didn't want the world to be like that. And he says he suspects that's behind a lot of the materialism and things like that in his field, is they don't want there to be a God. They don't want the world to be like that. And my roommate, when I was an undergraduate, was that way. He was an A+ student, very bright. And he gave me an analogy, didn't like the idea of God. He said it's like he played a game called Dungeons and Dragons, and the dungeon master who can change the rules. And he didn't like that idea. He said there's somebody outside the system. C.S. Lewis said the same thing. He said materialism made it feel safe for him. He didn't want the world to be like that. So that's why he was attracted to materialism. So there's all those factors going in. And I could even go through more factors. There's also a certain arrogance that comes into play too.
Yeah, it
So I
really
think
makes sense.
a
Yeah.
mix of good, a uh, mix of rational failures, but also problems with what they see of people that are religious that turn them off.
Okay, thank you. And after all these years, Dr. Collins, how certain are you after decades of studying this topic that God really exists? Has your faith in God grown to years, or it was weakened?
Oh, it's definitely grown. I think a turning point for me was 2008 when I published an article um, in the Philo, which was that leading atheist journal, was an invited article on God and the laws of nature. And what I showed is that the laws of nature, the regularities in the world, like masses always attract each other. One view is that just happens. There's no explanation, just a brute fact. And then another group of people, necessitarians, a lot of them aren't theists, say if you believe that, you'll believe anything. It'd be such an enormous coincidence. It's far worse than coin coming up a million times on heads for no reason. And they say if you also believe that, you wouldn't expect, we have no reason for these regularities. You shouldn't expect them to continue, and we all do. So my intuitions were very much in line with the necessitarian intuitions. But they thought they had an explanation in terms of universals. But what I was showed in that article is that I think I showed is that when it came to the actual laws of nature, which were what I call functional laws, theirs were just as bad. They had just the same problems. And only theism could survive that for the reasons I said. You get rid of the coincidence. They had to have coincidences at the level of necessities, that why you got simple, intelligible laws and all that sort of thing. So for me, that view, I just could not see how that view could possibly be true. I mean, I am with like David Armstrong and others who now those are atheists say, if you believe that, you'll believe anything. It's just ruled out for me. And even a lot of people who believe the regularity theory admit the intuition. They just think God doesn't do any better. And I argue, that's the coincidence problem with God that I talked about at the very beginning. So to me, that was just very convincing. And then, since that time, I've had off and on religious experiences just meditating on that issue, I begin to sense an underlying intelligence. But I would say, and then there's the fine tuning, and then the fine tuning for scientific discovery that I ran across, and it was predictive, and it kept turning out. So those were the real big ones for me, along with not being able to see how our minds could evolve to understand the underlying structure of things, because our minds only under a pure naturalistic evolution, only for survival, but yet we seem to be able to understand, go far beyond your understanding. So I would say my level of conviction is very close to 100%. I just can't, to me, it's like almost, unless you showed God with just a contradiction, anything's better than believing that it's all the regularities. It just happens, and there's no further explanation. To me, it's just outrageous. I mean, I don't see how people believe that, but I do, but I just don't get it. So that's where I'll stand. Then you add that to fine tunings and all this stuff.
Yeah, I share that conviction also. So yeah, we are on the same page. But what other arguments would you use besides fine tuning? Can you name other arguments for God that you use and
So
prefer
we,
to? Yeah.
yeah, this would be the argument from the laws of nature, for one thing. That was the other one but that's similar to the fine tuning, so it goes off the order of the universe. Um, Another one that's I find convincing is I had mentioned that is the epistemic argument, that I call it the epistemic argument. That is that if purely naturalist, I believe in evolution, but I think there was some guidance, or our minds did completely evolve by natural means, a random chance, because I think evolution can only account for our ability to survive, reproduce. But being able to do mathematics, for instance, um, being able to advance mathematics, being able to do philosophy reliably, um, being able to understand the fundamental structure of the universe, which requires intuition about how the universe is likely to be structured, intuitions about simplicity and elegance and all those sorts of things, as Einstein testified to, and others. Those intuitions are at all reliable, cannot be accounted for by this natural selection. We wouldn't have expected that at all, because they wouldn't be useful in survival. And they can't just be accounted for by kind of general intelligence, because they seem people that are intelligent in other ways are often not very good at mathematics, for instance. So there seems to be some kind of special module in the brain or mind that can do this stuff. And if that's right, then you can't just account for it by our survival, because ability to survive had nothing to do with the existence of whether you were good at mathematics or not. In fact, if you're good at those areas or good at philosophy, and they have to be, if they claim that our philosophy is unreliable, then they've undercut any reason for atheists believing for what they believe. So they can't really got to think our philosophy, because that's a philosophical thesis. So in that case, in fact, being good at those things would probably be hurtful for survival, because you'd be spending your time thinking about that instead of, looking out for the lion, tiger in the bushes, right? Just sitting on your rock there thinking about that. Oops, I got eaten. So you'd win at what they call the Darwin Awards, people that do stupid things and they die because of it. So that's another argument I consider pretty powerful for the existence of God. So that's an argument from reason. I would say, there's a classic argument of it seems to me that God is our foundation of our own epistemology. God is needed to ground our epistemology. Also, our value of truth. I think valuing metaphysical truth makes way more sense under theism than not theism. And the moral argument doesn't tug at me near as much as at other people. And then there's the cosmological argument. To me, they're kind of somewhat confirming, not core to the reason I believe. And of course, having some religious experience helps, and sense of the transcendent, which I think is kind of hard to account for. Let me think if I think of anything else. Right off and I couldn't possibly leave it a reductive materialist view just because of mathematics. I don't see how mathematical truths seem to me you cannot count for them under materialism, and yet we have very strong arguments for believing in them. So it's all those sorts of things. So I guess I'll just leave it with that.
Yeah, what about the applicability of mathematics?
That gets back to that was the fine tuning. So I just labeled that under fine tuning. So I think
okay.
the applicability of that's related to the fine tuning, that mathematics is so applicable. And that's the sense in which simple, elegant mathematical systems work so well. It's not that, 2 + 2 is going to always equal 4. If you could account for mathematics without God, being in the mind of God, then any world in which it existed, 2 + 2 would equal 4. Okay. So that it's not that aspect of the applicability. When we construct part of constructing mathematics, as J.L.G. Hart had, turn of 20th, leading mathematician in year 1900, said, it's finding beautiful and elegant structures. That's what we're looking for, not just any old structure. And when we do that, like the complex numbers are one of the most beautiful structures, that is central to quantum mechanics. You can't do quantum mechanics without the complex numbers, or what they call isomorphic, having the same as that, and just put it in a different language. So, and then group theory, same way, all that stuff was amazingly successful in physics, and yet it was elegant mathematics. People first came up with it. So that would be under the applicability of mathematics. That's a kind of fine tuning and partly almost a fine tuning for discovery that is made so we can discover it. When we look for simple and elegant theories, they often turn out, and mathematical ones, even if they're in these completely abstract mathematical systems, they turn out to be true. And I would say, along with that, quantum mechanics, I think seeing how quantum mechanics works, this elegance mathematics underlying everything that keeps going on, I just don't see how that could be by a brute fact. I mean, if it was, why would it even continue? Why would the equations continue applying and be so elegant and discoverable by us? Make any sense to me? So a lot of those are around order of the universe is probably the most impressive for me. Then our minds being able to understand that order, impressive. And then maybe you could go us have the consciousness being the existence of consciousness and being able to connect up with the world. But that's a kind of fine-tuning psychophysical laws. So that's another fine-tuning kind of argument. So those are the most impressive to me. Fine-tuning broadly understood. And then
Yeah, and what about sorry.
Go ahead.
Yeah, what about the colors, beauty in the world, maybe music? Would you that count by fine tuning or?
Yeah, well, the colors and beauty, some of that can be explained by the color and beauty and the surface level color and beauty, you could explain it by physics or why we respond to that beauty by natural selection, right? Sexual selection. So I wouldn't go that level of beauty, but that the criterion of beauty applies at the fundamental level of elegance and beauty. And that has been used with such success that even people like Steven Weinberg admit, who's a leading Nobel laureate in physics as an atheist in his book Beautiful Theories, that how uncannily successful that is. That is where you need theism comes in. But otherwise, you could just be a materialist and say, well, there's just colors. Why is there colors? There just are. And then we have colors. We respond to colors because of there's a sexual selection.
Yeah, but it could be gray all around the world. So only one color. Yeah.
Well, you might think it's designed by God. You might think it's that, hey, this is great that we've got a colorful world and our eyes can pick up all those colors. But there's limitations. We can't see ultraviolet, for instance.
Yeah,
And there's
yeah.
fundamental physical reason for that, actually. That so, but you might think, well, that's, a beauty of the design of the world that we have this kind of world. But I wouldn't use it as an argument for God. Because then the other side's going to say, well, why is there so many ugly things in the world? And when we get right, there's a lot of ugliness. So, and I'd have a hard time seeing how you get fine tuning going there.
Yeah. And music, would you say that's wonderful? And yeah.
I think music is we have such a deep. It seems like people say that's all part of the our could our minds and their sense of beauty, a transcendent sort of beauty, have really evolved. So that's just a question about where did our mental capabilities come from, that we have this transcendent sense. That all merges into both religious experience and the epistemic kind of argument I offered against naturalistic evolution.
And would you use this is last, sorry,
Okay.
about column argument? Would you use that as a good argument that universe has a beginning or what?
Well, it may be a good, I don't want to do the a priori version of the Kalam cosmological argument. partly because, if you do the a priori version, there can't exist an actual infinity. Then you have to have this weird thing of God being timeless and then entering time. And, Craig argues, well, a universe coming into existence out of nothing is absurd. Well, one could argue the same thing about that idea of God. So you'd have to show the idea of God is less absurd. And I haven't seen that done. So that version. What about the version where you have just all the matter suddenly, coming into existence, and God creating that matter into existence? Well, there it depends, your intuition there depends on there being a time before. So it depends on an A series of time. And honestly, time puzzles me a lot. So it's never grabbed me as I think there's something to it. It's confirming evidence. It's just that I think an atheist is going to say, well, it just the universe always existed as this four-dimensional block universe idea, the eternalist point of view. So they could always respond to it that way, or they could say, well, maybe the universe eternally existed. There's various eternal existing universe models. Now you might think those are implausible, but that's with our current science. But are they? Maybe we could think of a way around them. You might say, well, you'd run into the low entropy problem, but then that kicks it back to the fine tuning. So you don't have really a separate argument there. So I'm not, I mean, those are all the things that one could develop in science. And I'm not convinced by the ABG theorem. I think that already assumes assumption that these cosmologists would deny that the universe had a beginning. So they would just deny that there's a beginning to the universe and they say there was something before. They haven't worked out one that works really well, but apart from like the entropy problem of low entropy at the beginning of the universe, which is a fine-tuning issue, I don't know whether the universe might have, could have existed forever, that you can't develop a model in which that's halfway coherent. And you can't just say it's puzzling how this could be, because they will say, well, God's creation is puzzling.
Yes, thank you, Dr. Collins. And at the conclusion, can we say something about fine tuning? Because that was the main topic. We diverged a little bit, but is there some history about this argument and where is it going? How is it developing? I believe in Romans 1, 19 to 20, it is mentioned also. So can you mention some history about that argument and give some conclusion for the
Well,
end?
it is a version of the design argument. The design argument's probably one of the major arguments throughout history, going back to the Stoics in ancient Greece, and also occurs in India, in early Indian philosophers. So it's one of the major arguments for theism, and then reaches kind of a high point with William Paley around 1900 with animals and plants, and then there's Darwin's theory seemed to undercut it. But then you got it at the deeper level, the fine tuning of the universe. It doesn't get undercut by Darwin's theory. So then it comes resurfaces again. In the 70s, 80s, people started really finding it out about the structure of the universe. I think in terms of the fine tuning for life, it's not like there's going to be any new major discovery that's going to significantly strengthen the argument. It's all philosophical objections right now and hypothetical, like mini universes for that. So there's just some philosophical work that people do that gets more and more abstract. But I don't think it's anything there is going to significantly strengthen it. For me, I mean, I'll just speak for my own work. I think this fine tuning for scientific discovery is where the future is going, and that has to get out there. In fact, there's a deeper sort of fine-tuning going on. It seems like the parameters are set to give the most powerful effective signal that the universe is fine-tuned for discovery. So there's a further setting, but there's within the range of fine-tuning for discovery, there's these very small sub-ranges that would make a more effective signal. And the core idea there is that you using the parameters to signal something. So you'd want the parameters associated with discoverability in a way that couldn't be explained easily by chance. So what you do, you'd want to put the parameters within those discovery optimality regions. You put them even to a region where there's a peak of a significant contributor to discoverability. That's a small peak and be very unlikely to fall under that peak. And the peak would further associate the parameter with discovery. And then you can get a set of criteria for it. You want to be highly recognizable. The smaller the peak, the better. The more important the peak, the better. And using those criteria, you can narrow down the peaks, and you can look at particle physics where you can get a really get clear calculations of anthropic ranges and then show they're very small in comparison to that. And they all turned out, all the ones I looked at, with the predictions of this hypothesis. You can make definite predictions with this hypothesis of where you'd expect them. The simplest being you'd expect them to be under a contributor peak within the optimality zone. And that just in a very basic calculation is like 1 part in 10 to the 10 to the 23rd power of that occurring. And there's no possible explanation for that under a multiverse. So for me, that's where it's going. That's where my work is at today. In particle physics are most of the cases, and then one major case from cosmology. Because my idea was to show that this range is much smaller than the anthropic range, and only in cases in particle physics and cosmology, because a lot of the parameters have no effect on life. Like, at least in our current universe, like the particles in particle colliders are so heavy that they only can exist in colliders, and they decay away like in less than a trillionth of a second, and they can't affect life. They don't exist long enough. So you can get a nice anthropic range for them. If they're all outside a certain range, they cause the Higgs field to go unstable and the universe to disappear. But inside that range, they don't affect life. And so then you can have a nice discoverability signaling range, very thin, for each of the parameters. And they apparently they're mostly independent of each other. So you get this really strong case for the fine-tuning for discoverability signaling. So that's work I'm finishing up now.
I cannot wait. And so there is fine-tuning inside fine-tuning. It's interesting.
Yeah, fine-tuning for scientific discovery, and then inside that for discoverability signaling. So that
Yeah.
it's like if God wanted to send a signal, how would God do it? Would to send something with whatever you're signaling. So it's the values of the parameter get associated with discoverability. And the way to do that is put them on the P within the discoverability optimality range, but that might be kind of large. Like if you have I give an analogy of the car. Like if in a car, you can, if you talk about a quality optimality range, there's a lot of contributors to quality, right? So if you change your fuel to air ratio, it would affect the comfort, safety, gas mileage, etc. So that might be quite a broad, but there might be within that range, there might be a real thin peak for, let's say, fuel economy for highway driving. So if you put it under there, that would really strongly associate that parameter with a quality contributor associated with quality. And if you had like 6 different kinds of cars the company produced, and every one was associated with some contributor to quality like that, air pollution or something else, within that range, you would just say, well, they must have wanting to communicate to us. It wasn't by chance. They were either trying to communicate to us or doing it for fun. This idea that, the car is set for quality. They're trying to quality. Every single one of them gets associated. Well, that's what happens in the case of the parameters. Like over and over again, they get associated in a natural way with discoverability, ability to discover things.
Incredible analogy. I like it. And this is last. Do you have any advice for people that watching this video? Some apologists, young philosophers, students. Can you say any advice for those who want to learn more about fine tuning?
Yeah, a good person to go to is also Luke Barnes. So I'd also suggest Luke Barnes. He's an astrophysicist in Australia. So I've got some, easier articles like one with infidels.org that's online. You could read some of mine, but you could also, I would look at Luke Barnes's book. I'll give a plug for it. He's careful and is in astrophysics. It's used to communicating with the public. So FineTuning. So the other thing is just be honest. I think you don't need to, we don't need to just, I think the job of an apologist is to honestly explicate how they see the evidence and not try to persuade others, because that's God's job. Your job is just to explain why you think the evidence points in this direction. So that's kind of the big advice I give to people that are apologists. I'm also coming out, if you do Christian apologetics, of how to go from, I find very convincing, it's going to be published here not long, go from theism to Christianity in a very direct philosophical way.
Okay, Dr. Collins, thank you for sharing your insights on fine tuning. This has been a fascinating discussion. Dear audience, if you enjoyed this conversation, don't forget to like, subscribe, and follow NT Podcast for more deep dives into science and philosophy. See you next time.
Okay, thanks.